Hello and welcome. My name is Chris Carr, also known as Natural Body Man, and I'm so grateful for you to attend our presentation today. Today we'll be looking at how hormone actions interact, especially taking a nice look at how second messenger molecule hormones work. First of all, hormones, they're in our body and they cause actions to occur in our body. We usually call these scientifically physiological actions. There's two different types of hormones. One is a steroid hormone and one is a non-steroid hormone. Examples of some kind of steroid hormones are basically aldosterone, cortisol, estrogen, testosterone, progesterone, and vitamin D. Now, the majority of the other hormones, which are non-steroid hormones, 90% of those are proteins, like your catecholamines, epinephrine and norepinephrine. Insulin, which is a great hormone, it's also very anabolic. And also, like I said, melatonin. I didn't say that, did I? Melatonin. So, these hormones are less powerful than the steroid hormones. So when they want to cause a physiological action to happen in our body for us to sweat or for us to produce muscle contractility, they need to talk, aka to a second messenger molecule that's hanging out on the outside of that cell, okay, on the receptor. And then that molecule, that second messenger molecule, will then transfer the information to the cell in a variety of places. The mitochondria, where the oxygen is taken, the RNA and the DNA and RNA messenger molecules, where the genetic transcription code can change how you physically are, or mental, emotional, when you go into the cognitive. But to make things simple, that's how it happens. Non-steroid hormones go to that molecule hanging out on the cellular membrane, and then boom, that second messenger penetrates through to the vital places. Okay? So there's three main mechanisms that are used. Two of them are non-steroid hormone mechanisms, and one is a steroid hormone mechanism. The adenosine cyclase mechanism is non-steroid, and basically it occurs in 6 steps. Okay? If I don't get all the steps, read your textbook, but these should be all the steps. First of all, GDP is basically the beginning where it activates GTP. And from there, that's step 1. Step 2 is where GTP activates adenosine cyclase mechanism. And then from there, ATP activates CAMP, which is a second messenger. And then from there, the 4th step is where GTP comes back to GDP. And basically now the physical action is resetting itself because GTP has now gone back to GTP. From there, your second messenger molecule does its action, and it activates protein kinase A. And from there, basically, your proteins phosphorylate, and step 6, a physiological action occurs. So that's the adenosine cyclase mechanism. An example of this would be with vasopressin, in how your blood volume will increase, so you dilate, and from there your blood pressure will increase. As your blood volume dilates, as the liquid in the blood dilates, boom, the pressure increases. Our second mechanism is the phospholipase C mechanism. That's also non-steroid. And the second messenger molecule in this is IP3 and calcium. Okay? Here are the steps. There are 5 steps on how they work. First, GDP activates GTP. From there, second phase, second step, GTP activates phospholipase C mechanism. And then this is where PIP2 and IP3 are activated, the second messenger molecule. Doesn't this sound great? The second messenger molecules. And diagrosol is activated, and then what is the second messenger molecule at the end of all this is basically IP3 and calcium. And then from there, step 4, your GTP now deactivates itself back to GDP to get ready again for more physiological actions. And then from there, your second messenger molecule, IP3 and calcium, combine also with diagrosol to activate protein kinase C, which is your proteins. And then from there, your proteins will phosphorylate and incur a physiological action in step 5. It really could be 6 steps, but I call it 5. From there, your tyrosine kinase mechanism, that is your steroid hormone mechanism, and that basically works with glycogen, which is your stored sugar, and glucose, and it makes your blood sugar, glucose, turn into a stored form of sugar, glycogen. This happens without any second messenger molecule. So the tyrosine kinase mechanism is done like this. Beta activates tyrosine kinase alpha, and then in step 2, insulin activates tyrosine kinase receptors. In step 3, phosphorylation of proteins occur which activate GLUT4. And then from there, basically your blood sugar glucose activates glycogen synthase, which then yields our product of glycogen, which is our stored sugar. And that is how our steroid hormone works, via tyrosine kinase mechanism. So again, it can sound very complicated, but in order to understand the concept, basically we have steroid hormones, which penetrate right through to cause the physiological action to occur, and non-steroid hormones. And they need help with second messenger molecules. 90% of all non-steroid hormones are proteins. Okay? So stay tuned for this and more. I look forward to you getting a great grade on your test, an A+ or an A-, or just a good grade. And thank you very much. This is Chris Carr with Natural Body Man. Remember, have fun and exercise. Yeah! Okay.